We're now at the 10-year anniversary of the discovery of the first piece of physical evidence in the case of the missing Malaysian airliner MH370. The badly damaged right flaperon washed ashore on La Réunion, a French island in the western part of the Indian Ocean on July 17th, 2015, immediately caused a tremendous worldwide sensation. Today, I have some exclusive and very exciting evidence that relates to that discovery. New data that will help us understand just what that debris means about the fate of MH370. And the only place you're going to hear about it is right here. And that's coming up right now. Hi, everybody. Jeff Wise back with you as ever. For full show notes and discussion of today's episode, please visit findingmh370.com, where you can sign up for a free newsletter as well. Now, when the Flapron came ashore, it was very exciting because it seemed that at last there was hard physical proof that the plane really had gone into the southern Indian Ocean. And hopes were high that the Flapron and the marine life growing on it would finally provide unequivocal evidence just where the plane went in the ocean, where it had crashed. But as I've described previously in this podcast, on closer examination, it turned out that it was actually had a lot more puzzles than previously believed. The authorities struggled, for instance, to understand how it could have drifted from the crash zone all the way to La Réunion in just 15 months. Their model suggested, at least initially, that it should have taken significantly longer. Then there was the problem of the barnacles, a couple of problems, really. These were goose barnacles of the species Lepas anatifera. They grow all over the world in temperate and tropical oceans. In their larval stage, they're little critters that sort of swim around in the water. They disperse all throughout the ocean. They're looking for something to attach to when they become adults. And they glue their head onto some kind of hard substrate. They extend their feet into the water and they pluck food out of the water that flows past. So they're everywhere. If you throw any floating object into the ocean, pretty much anywhere, within a week, you will start to have little baby Lepas growing on it. This is a real pain in the butt if you own a boat, but it's really great as a potential clue for how long something has been in the water, because basically, whether you want it to or not, anything that goes in the ocean is basically going to get a natural data logger attached to it. We talked a lot about this in season 1. Suffice to say, for present purposes, that the scientists who've studied Lepas in order to estimate how long things have been there in the water, like fishing nets, tortoises, even dead bodies. There's been a lot of research into this over the years. But if you combine all of that with reverse drift modeling, you can figure out where these things started their journey through the ocean. Here's the thing, though. You can use the size of the barnacles to estimate how long something has been in the water, but only if you know how fast those barnacles grow. And that's been something we've really lacked a lot of good data on. Back in 2015, when the Flapron showed up, we didn't really have much good data on how barnacles grew. But because of the mystery, because MH370 was such a famous case, and because Lepas anatifera was such a key element of it, it really spurred a lot of new research into that question. And some of the assumptions that had been made at the time turned out to be wrong. For instance, researchers had assumed that Lepas grow in the same way pretty much all over the world. It turns out that they don't. Researchers who looked at barnacles growing in the cold water currents off the coast of South America found that they only got to about 20 millimeters. That's much smaller than barnacles on the Flapron. On the other hand, researchers in southeastern Australia found that they could get as big as 45 millimeters in just 30 days. And that's way bigger than what they were found on the Flapron. So what this tells us is that if we want to use the flaperon barnacles to tell us how long the thing was in the water, we need to know specifically about how barnacles grow in that particular part of the ocean, namely the tropical Western Indian Ocean. And over the years, some really intriguing work has been done in those intervening years. In one study, researchers in Tanzania found a tortoise that had washed ashore covered in Lepas. Now, bear in mind, tortoises do not live in the ocean. Tortoises are, the famous Galapagos tortoises, these sort of ancient, crusty, big domed tortoises. They live on dry land. And so, but occasionally they will fall into the ocean. Maybe somebody throws them in the ocean. However they get in the ocean, they will float. And they can live quite a long time. Tortoises have a very low metabolism compared to mammals. And I guess they will just float and float and float until they either die or they wash ashore. In this case, a tortoise had washed ashore in Tanzania. It was found. It was in a very sickly state, but they nurtured it back to health. Pictures were taken of it when it came ashore. And by sort of photogrammetry, by looking at the tortoise and then its known dimensions and then how long the barnacles were compared to that, researchers were able to determine that the barnacles were about 2 centimeters long, aka 20 millimeters. And in trying to understand what that meant in terms of how long the tortoise had been in the water, they referred to earlier findings in a study that I haven't been able to find, but this paper refers to it, that there had been fish accumulation devices. These are called FADs, F-A-D. Fishermen put them in the water. They drift and they grow seaweed and biofouling, and then the fish are attracted to that. And then the fishermen can go fish for the fish accumulation devices. And these also have GPS data units on them that transmit the location via satellite so the fishermen can go find them. And so somehow the researchers glommed onto these devices and managed to measure barnacles that grew on them. And the study found that after 11 weeks in the water, or a little short of 3 months, these devices had barnacles that were 30 millimeters long. So based on that, they figured that the tortoises had been adrift for 6 or 7 weeks. Okay, so the barnacles on the Flapron are a lot bigger than that. How much bigger? Well, I recently gained some significant new insight into this. This is actually a pretty exciting discovery in itself. When the Malaysians released their final report back in 2018, they included as an annex to that a paper by a French marine biologist who had studied the barnacles. And his paper revealed that the largest specimen was 36 millimeters. Now, we also know that the French had loaned out some other specimens to other scientists that were significantly small. They were about 25 millimeters. At the time, it really wasn't clear why the ones that they lent out were so much smaller, because they're smaller, that means they're younger, which means they weren't in the ocean as long as the whole journey of the Flapron. It means that they really weren't as useful in providing evidence about the Flapron's full journey. So that was a bit of a mystery. Well, for many years, the French were really secretive about what they had. And I have talked to marine biologists who wanted to get access to this data. The French were not really being helpful. But gradually, they kind of got worn down and they grew more open about what they had. They shared more information. And one of the people that they shared pictures of their samples with shared them with me. And with the help of volunteers Keeley and Brett Glossop, we've been able to do some photogrammetry to figure out the size of the population of animals just by measuring the ones that we're able to get a clear image of. You can see in these pictures that they weren't intended to be used for this purpose. You can see some of them, a lot you can't really see, but just sort of by presuming that the ones we're seeing are kind of presenting themselves randomly, as it were, we can hopefully get a sense, at least by measuring those, of what the entire population looks like. And it turns out that the population size distribution looks like this. The biggest barnacle there is 36 millimeters, which we know. And then there's a handful of others that are bigger than 3 centimeters, bigger than 30 millimeters. And most are between 20 and 30 millimeters. So based on the tortoise paper, it looks like this population is older than the 11 weeks that it takes the biggest barnacle to be 30 millimeters. How much older? Well, back in season 1, episode 24, I interviewed Dr. Martin Stelfox, who had conducted an experiment where he let Lepas grow on buoys in the Maldives. He wanted to understand how barnacles grow in that part of the ocean, which isn't too far from the area we're interested in, the Western Indian Ocean, a little bit further south. So his particular goal was he was studying. He was sort of an advocate for sea turtles, and they get caught in these nets, ghost nets that are used by fishermen and then abandoned, and they entrangle sea life like turtles. So he basically wanted to find out where they're coming from so he could protect the turtles. So the drift nets would show up with barnacles growing on them. He wanted to know how old those barnacles were so he could do reverse drift modeling and figure out where the problem was coming from. To order to calibrate the barnacle growth, he let Lepas barnacles grow on moorings. So these are fixed in the seabed, they float and the barnacles grow on them, then you can study them and measure them. And his experiment was really unique because his team was able to observe individual barnacles as they grew. So we really can see for the first time how an individual barnacle gets bigger over time. Maybe they grow slowly at first, then they have a growth spurt, and then they kind of level off after a while and grow more slowly, like a lot of things grow that way. Anyway, the paper that they published showed that they had a growth curve that looked like this. Now, this chart doesn't show how big the biggest barnacle is. What it's showing is the average size of the ones they're measuring. So after 105 days, or that's about 3.5 months, the average size was 27.9 millimeters, and the biggest was 35 millimeters. And, well, that's about what we see in the Flapron. So based on Stelfox's data, you might think that the Flapron had been in the water about the same amount of time, 3.5 months. But here's a question. Do barnacles grow the same on floating objects, the same way that they do on fixed buoys? I mean, it seems a reasonable assumption. You know, they're both growing in the same ocean, so it seems similar. But maybe not, because, you know, the water flows more past a fixed mooring than it would on a buoy that's floating with the current, right? And since Lepas feed by plucking food out of the water that's flowing past it, you might expect that it would eat more food and grow faster on a fixed mooring than on a free-floating object. Just a theory, just a possibility, but one that sort of bears investigation. So to really understand how the Flapron barnacles grew, ideally, we would have a reference population, a population that we know how long it's been in the water and where it's been, that has been floating freely through the ocean. Okay, that's great, but how do you do that? That sounds really hard because, you know, the thing you're trying to study is floating freely. And it's in the middle of the ocean. How the heck do you get to it? Well, at the end of season 1, I did an episode where I did a photogrammetric analysis of barnacles that had been found growing on a capsized boat that had drifted from Australia to the French island of Mayotte, which is near Madagascar. And it had taken 8 months. Now, I only had usable imagery of a very small sample. There was one image in particular that had been taken of this boat that really showed clearly the length of some individual barnacles, and you could see some numbers in the background that I was able to get the dimensions of. So that would allow me to determine the length of these things. And it seemed that the largest of them was about 40 millimeters. And that seemed to me to fit with Stelfox's data and suggests that Lepas will get bigger. If you give them time, they will get bigger than they were on the Flapron. And the Flapron, that would mean that the Flapron spent less than 8 months in the water. But as I said, the number of barnacles in that image was quite small, and I wasn't able to measure the individuals directly. They were kind of at an angle to the boat numbers, so I wasn't 100% confident that I was really getting it right. That evidence left something to be desired, but it was an intriguing kind of hint. So what would really be useful would be to retrieve multiple objects that had been floating out in the open ocean and then compare how the barnacle populations on them grew. And that idea led me to the Global Drifter Program. I initially talked about it in season 2, episode 12, where I talked with Andy Sabrandi of Pacific Gyre Inc., which is a company that makes these buoys. They get deployed by scientists in the water, in the ocean, and they drift around freely. And every hour, they transmit their location, their GPS location, via satellite. They also report the water temperature, the air pressure, things like this. And Andy told me that the location of these satellites, the location of the buoys, can be seen on this publicly accessible website. So what you could do is wait until one comes ashore and then, try to find a local to go retrieve it. And we tried to do that, actually. In episode 16, we tried to do that. It was a partial success. A drifter came ashore in Kenya, and we saw where it went ashore. We asked the local hotel owner. We explained the project to him. He was saying, sure, and he went to retrieve it. By the time he actually managed to retrieve it, somebody else had already found it and scraped the barnacles off. So that it wasn't quite a success, but it showed us that the concept was at least workable in principle. So I kept at it. A volunteer named Rochelle Reynolds helped me keep track of where these things were going. We had a lot of failures. We had a lot of near misses. Eventually, we were able to retrieve a drifter in Hawaii on the island of Kauai, came ashore next to a golf course. The groundskeeper there was able to get that, send me the barnacles. We had, after that, we were able to get 2 on the Pacific coast of Australia.
Piece of an international puzzle has washed ashore in central Queensland, one that could help solve one of the world's biggest aviation mysteries. After drifting at sea for nearly 2 years, a barnacle-covered buoy could provide experts with vital clues to pinpointing the location of MH370.
Queensland Surf Lifesaving Club got the call from New York, and the mission to find the buoy before evidence was tampered with was on.
Mackay, why Mackay? And then all of a sudden it's on the Mackay beach. We found it, yay! And I sent Jeff an email straight away, and he was over the moon that we went above and beyond to find it for him.
After being deployed east of French Polynesia, the buoy spent a total of 688 days at sea before washing up here in Mackay. Despite being on opposite sides of the world, the enthusiasm is shared.
And so we finally had real Lepas data from ocean drifters, and I think that will be really useful going forward. And I think ideally someday I would like to have data sets, meaning collections of Lepas from drifters with known trajectory from every ocean in the world. And so wherever something washes ashore, we'll be able to say, okay, this looks like something that's been in the water for X number of weeks or months. But all of this data was not really directly useful for the flaperon question, because it seemed that these particular populations either grew significantly slower than barnacles do in the Western Indian Ocean, or they had suffered significant predation, meaning it seemed like a lot of the population was missing. When barnacles die or get eaten, they'll leave behind like a little clunky disc where they were attached. So I was a little bit stuck. After many months of working on this problem, I had become convinced that the methodology was sound. It would work in principle, but I hadn't managed to collect a single one in the Western Indian Ocean. I knew it was just a matter of patience, waiting for our luck to turn, and finally it did. On June 6th, 2025, Rochelle and I noticed that a drifter was heading right for the island of Zanzibar, and it seemed that there was a good chance that it might come ashore. But we'd seen this happen before, and we just had either it had come ashore and we couldn't get it, or it just had they move very randomly. It's very hard to predict what they'll do. But in this case, lo and behold, on June 10th, it came right up to a small island off the coast of Zanzibar called Chumba. This is a private island and preserve that tourists can visit, and it also has its own staff of scientists. So I reached out to them, and they seemed quite interested in helping. But there was something strange about this buoy. It kept bobbing up and down, drifting north and south of the island with each tide. The tide would come in, it would go one way, the tide would go out, it would go the other way, but it wouldn't actually come ashore. And this seemed very strange to me. Something to bear in mind is that by the time the location data gets to the public website, it's 4 hours old. And it can be really tricky to figure out where something is now when all you know about it is where it was 4 hours ago. Things can move pretty far. So long story short, the buoy eventually left Chumba and it started to head north. And I was deflated. I figured, okay, we've missed our chance yet again. But then we got a big lucky break. The buoy just stopped again right in the middle of a channel a few miles from the main town of Zanzibar. And I had never seen anything like this before. I had never seen a buoy just stop in the ocean. And I looked at Google Maps and I found a paddleboard tour operator called Two Winds that was located just on shore of where the buoy was stuck. And I reached out to him. This is an operation, it turns out it's run by two expats, Josh and Arsheen. They're a married couple who've been doing development work on the island for years. And they started a paddleboard company to help financially support their NGO project, which is helping poor kids get ready for independent adult life. So really amazing people, really helpful, really, publicly spirited people. So I called them up and they very graciously offered to go out and get it. They rented a boat and they went to get the buoy. And it turned out it was really $1 million haul because the buoy and the sea anchor attached to it were just absolutely covered with hundreds and hundreds of big, fat, juicy barnacles, as you can see in these pictures. Josh was gracious enough to talk to me about how they retrieved it.
My name is Josh J. Speaking to you from Zanzibar, which is a small island off the east coast of Tanzania, situated in the Indian Ocean. And my wife and I, we run a paddleboarding company here. Originally from the UK. I came here actually to do some development work. And then I've had a few different jobs through the years and eventually took up paddleboarding here, and now we have set up a paddleboard business. We are situated right on the edge of a mangrove forest, which helps protect the coast here, so we get nice, calm, flat waters through the forest. So we will actually teach people how to sup, and we'll take them out on a nice guided tour through the forest. We're also doing some education. Sorry, that's my dog. Some education on the mangroves as well.
I was paying attention through the NOAA website of this particular drifter, and I've been watching a lot of drifters in that part of the Indian Ocean. A lot of them come ashore in Tanzania and Kenya, on Zanzibar and some of the other islands, Mafia and so forth. But it's really tricky. It's really hard to kind of get them. Sometimes they'll come ashore and just like someone will pick it up and walk away. I was watching this thing and it was sort of hovering around Chumba Island, which is a couple miles south of you. It was sort of hovering around the island, which is very unusual. And then it broke free and it went north, and then it got stuck. You were saying in the middle of a ferry channel, and we don't really know what, but you guys were busy. The weather wasn't that good. But then a few days later, you were able to rent a boat from the capital of Zanzibar and go out. Is that right?
Yes, yeah, exactly that. And we followed the kind of latest GPS signal in order to kind of locate it. It was quite close, so I think it was still snagged on something. Because it was within the ferry crossing channel, it could well have had the sea anchor got snagged on kind of the rocky outcrops there, because there's a bit of a drop off. So it could have been pulling it in. There was a bit of resistance. The other thing I thought, I don't know if you can see here, there's still a bit of fishing wire that's been tied to it. So I don't know if what happened, it's still here. A lot of the local fishermen here will actually put down these fish traps or crab traps, and then they'll put a float on them, And we think that possibly one of the fishermen had thought this was a fixed buoy and thought, that's great, it's going to keep my trap safe and not wash away, and it will give me a good marker. So we think maybe he tied his fishing trap to it. So when we were pulling it in, we had to, I believe this snapped because there was a point of, as we were pulling, some resistance gave way, and I think maybe this actually snapped off. So that could have been the second it snagged. The first one, if it was near Chumbe, could have been it caught on the reef there. They have a very nice reef system. So it could have been on their reef.
Now, one of the other things that's really important as we try to collect these drifter buoys to collect more data is the visibility of them. It's really challenging, especially because the data is 4 hours old by the time it appears on the website. And so the buoy can move quite a significant distance by that time. There's a very large margin of error. This thing was, I think, even harder to spot than usual because you were saying that the current was actually dragging it underwater. And so it was fully submerged at times. And so it was because you knew more or less where it was, you were able to kind of focus on a particular spot. But the waves were like pretty modest. You sent me a video actually of what it looked like in the time. So the waves weren't that huge.
No, they weren't too bad. But I think if they had been higher, it would have probably made it near on impossible to find. But we could with a bit of, because we knew it should be in that area, we were really focusing efforts on finding it.
We had some problems with the internet connection during our interview, but I asked him to show me the buoy and some of the barnacles that they'd taken from it. Again, I just want to say how grateful I am to Josh and Arsheen for their help. And if you're ever in the amazing and historic cultural melting pot of Zanzibar, make sure that you go stand up paddleboarding with Two Winds. I'll put a link to their site in the show notes. Now, in one regard, the drifter buoy is a lot like the Flapron in that there doesn't appear to have been significant predation or mortality of the barnacles. They both seem to be very healthy populations. Unlike the Australia drifters, you can see that every nook and cranny that the Lepas like to live in has been settled. You don't see blotches that are left behind when Lepas die. So in both cases, both the Flapron and the Zanzibar drifter, you have populations that should be a good reflection of how long these objects have been in the water. The striking difference, of course, between the Zanzibar buoy and the Flapron is that the Zanzibar barnacles are significantly larger than the Flapron ones. There are so many hundreds of them that it's going to take a little while for us to do a full measurement and analysis. But I asked Josh to take some pictures of some of the bigger ones and just to give a sense of what they're like. And really what they suggest is pretty striking. The biggest one that he sent me is 46 millimeters. That's versus 36 millimeters for the Flapron. And so the Flapron had a lot of barnacles that were between 20 and 30 millimeters, with just really a handful that were bigger than 30 millimeters. The drifter has a lot between 30 and 40 millimeters. And we know that because the Zanzibar drifter was, a recorded scientific instrument, we know that it was in the water for 10 months. So that really seems broadly consistent with the picture we'd gotten from the Stelfox mooring data and that earlier FAD data. And again, this is really exciting data. This is new. This is the first time that anyone has collected a complete and robust data set of Lepas barnacles that have grown in the open ocean in the western part of the Indian Ocean where the Flapron was drifting. This is the first really good reference data set to help us understand what was going on with the Flapron. So what do I think? In my interpretation, I think it seriously undermines the idea that the Flapron went into the ocean in March of 2014. It supports the idea, which I've brought up before, which is that it probably went into the water about a year after that. I've reached out to two scientists who've been studying Lepas growth as a way to understand how things drift in the ocean. And I'm hoping that we can publish a paper, peer-reviewed paper, in a scientific journal in the not too distant future. But that is to come. I still haven't actually taken possession of these barnacles. I'm hoping that Josh and Arsheen, they've enlisted some local help to photograph all of them. And then hopefully they'll send it to me and we can really make a meal out of this amazing data. Now, ideally, what we'll do is repeat the process. Now, I got incredibly lucky with this one. But lightning doesn't strike very often, but it does strike more than once, hopefully. So I'm hoping that with Rochelle's help, we'll keep watching this website. We'll find other things that go ashore, get other helpful local people to retrieve and collect the barnacles for us. And then we can get, over time, a really robust sense of, yes, this is consistently what we find on objects that have been in the water for a known period of time. And we can really use this as Lepas can really be a data logger. They can really tell us anytime we wonder how long this unknown object has been in the water, we can know just by referencing the shells of Lepas anatifera barnacles. Okay, work to be done, exciting results, although already. Okay, there's one sour note that I really need to drop in here. The Global Drifter Project is part of an office of the U.S. National Oceanic and Atmospheric Administration. This particular office is called the Atlantic Oceanographic and Meteorological Laboratory. It is headquartered in Miami. They collect all kinds of data that help scientists understand the oceans and the weather and the atmosphere and all the things that they need to predict what's going to happen with the weather, and they can save people's lives. Unfortunately, the new budget that just got passed by a Republican Congress and signed into law by Donald Trump will eliminate this office. So the data we've collected might never be possible to be collected again. And this is just one small example of how America's leadership in the world scientific community is being gutted. It's being completely destroyed. Why? So that rich people don't have to pay as much in taxes. Now, before I leave you, I'm going to tell you about one more really interesting thing that Josh and Arsheen shared with me. As you know, one of the other major mysteries about the Flapron is how it could be that there are Lepas growing all over its entire surface. Both Australian and French researchers found that the Flapron, it floated in a certain way, with the aft end, the sort of jagged, pointy end, sticking well out of the water. So how come the part of it that was covered with lots of Lepas was sticking up into the air? Is it possible that Lepas can grow out of the water? I wouldn't have thought so, but I launched a Kickstarter to raise money to buy a Flapron and put it in the ocean to see what would really happen. Maybe I was wrong. Maybe because it would get splashed with enough water that Lepas could grow on this part that was out of the water. Unfortunately, I didn't come even remotely close to raising enough money. I'm deeply grateful to everyone that pledged and tried to help me get to the goal, but I didn't. So unless some rich benefactor comes forward, and that would be great. So please, if you're watching and you want to help, it costs about $50,000. But until that day comes, we will never know. We just can't answer that question. But again, we can try to chip away and find bits of data and evidence where we can. And here is such a little piece of evidence that I think sheds a little bit of light on the question. Zanzibar lies at the end of a pretty strong and consistent east to west current. It flows over the north end of Madagascar, and it dumps stuff from the deep ocean onto the shores of Tanzania. And Zanzibar is right there on the shore of Tanzania. So they get, on the beaches there, they get a lot of debris from the deep ocean that has just tons of Lepas growing on it. I mean, I've never seen Lepas growing on anything here on the east coast of the U.S. The currents just don't work that way. But so they're lucky in that regard. If you like Lepas, move to Zanzibar. And so they had sent me a picture of a soda can that had quite a nice population of Lepas on it. And of course, it made me think about the Flapron mystery. So I asked them if they would put it in the water and show me how it floats. And as you can see, the Lepas do a great job of really growing right up to the exact water line and not a millimeter more. So Lepas are a great way of telling where the water line of something is. They respect the water line. They are sea creatures. They don't grow in the air. Just another little bit of evidence that something is really pretty wrong, something we don't understand, something mysterious about how the Flapron floated, a bit of a paradox, something I will continue to work on and see if we can't find other economical ways to solve that mystery. You know, after all, MH370 is a really big mystery, and a lot of money has been sent fruitlessly trying to find the aircraft wreckage on the seabed. But I think that there's something that's more valuable than money when it comes to solving a mystery like this, and that is determination, a willingness to think outside the box and to work together. So many people work collaboratively, volunteer their time and effort, and that can really crack problems in a way that professionals can't. We will get there. I fully believe that we will solve this mystery, working together, keeping our minds open, finding clever ways to get data that, million-dollar projects can't. We are relentless. There are many of us, and we will solve it. I will leave it at that for now. This is Jeff Wise saying, see you next time.